Hey there, and welcome. Today, we're diving into one of the absolute fundamentals in any programmer's toolkit, Python functions. If you're looking to write code that's cleaner, more powerful, and just plain smarter, this is where it all begins. So, you ready to level up your code? Let's do this.
So, does this sound familiar? You figure out a piece of logic. It works great, but now you need to use it again. And then again over here, and again over there. Pretty soon you find yourself just copying and pasting, and your script is turning into this long, repetitive beast. Yeah, it's a super common frustration. We've all been there.
And this slide, well, it just lays it all out, right? On the left, that's the mess, the same code everywhere, which is a total nightmare to update. But on the right, that's the magic of functions. You write your logic one time, and you can reuse it forever. And if you need to make a change, you fix it in one spot, and poof, it's updated everywhere. It takes your code from this confusing mess to something that's just crystal clear.
Okay, so how do we get to this magical place? Well, the best way I've found to think about it is like this. You're creating a recipe. Yep, a function is basically your own custom reusable code recipe.
So here's the official breakdown. A function is just a named block of code that's designed to do one specific thing. The two words you really want to latch onto here are named and reusable. You give your recipe a name, and then you can call on it whenever you need it without having to rewrite all the steps from scratch. And honestly, it all boils down to just two simple steps. First, you define the recipe. In Python, we do that with the special keyword def. Second, you use the recipe. We call this calling the function, and you just do it by using its name. That's really it. You define it, then you call it. Simple as that.
All right, so we've got our two steps, define and call. Theory's great, but let's see what this actually looks like in real code.
Okay, and this right here, this is the whole concept in a nutshell. You see that line that starts with def my function? That's step one. That's us creating our recipe and giving it a name. The print statement tucked in underneath is the step in our recipe. Then that little line at the very bottom, my function with the parentheses, that's us calling it. It's like we're shouting to Python, hey, run that recipe for me now.
All right, so a recipe that does the exact same thing every single time? I mean, that's useful, sure. But what about a recipe you can customize with different ingredients? That's a game changer. And in programming, our ingredients have a special name. They're called arguments. So, what's an argument? It's really just a piece of info, a number, some text, that you pass over to your function when you call it. This is what lets you change how the function behaves each time, which makes it incredibly flexible. Okay, so how do we actually use these ingredients? Well, when you're first defining your function, you create little placeholders for them right inside the parentheses. Think of them like little empty slots, just waiting for you to drop the real data in later. And this example just shows it perfectly. In our function definition, num1 and num2 are our placeholders. Then, when we actually call the function, we pass in real values, like 5 and 4. What happens is, Python sees that 5, and it flows right into that num1 placeholder. It sees the 4, and that flows into num2. Now the function has the specific ingredients it needs to do its job. Okay, so up to this point, our functions have, well, they've done something, right? They've printed a message to the screen. But what if we don't just want it to do something? What if we want it to give us a value back, a value we can actually use later? This slide absolutely nails the difference. A function that just prints something, it's like a chef yelling out from the kitchen, "Order up!" You hear it, you know it's ready, but you don't actually have the food. But a function that returns, now that's like the chef walking out and handing you the plate. Now you actually have the result. You can save it, use it for something else. It's yours to work with.
And the magic word that makes all of this happen? You guessed it, it's return. Literally, whatever you put after that return keyword is what the function hands back to the rest of your program.
Check this out. This is a perfect example. Our square function takes a number x, calculates x times x, and then it returns that value. And look at how we use it. We say result equals square 6, the function goes off, does its thing, calculates 36, and then the return statement sends that 36 right back, we catch it and store it in our result variable. Boom. Now we've got the number 36 ready to go.
Okay, once you've got these basics down, you can start to unlock some serious power. Let's take a quick peek at a few ways to supercharge your recipes and make them incredibly flexible. So what if you have a recipe, but you don't know if you're going to get 2 ingredients, or 5, or maybe even 100? This is where args comes in. That little asterisk tells Python, hey, Just gather up however many arguments they give me, and it just bundles them all up for you into something called a tuple. So it doesn't matter if you give it 2 numbers or 20.
Now, keyword arguments. These are fantastic, especially for making your code easy to read. Instead of just relying on the order of the ingredients, you can actually name them when you call the function. It makes your code way easier to understand at a glance, and you're much less likely to make a mistake.
And then, for the absolute ultimate inflexibility, you've got KW-args. That double asterisk lets your function accept any number of named arguments. Python just scoops them all up and organizes them for you in a dictionary. So you could just throw in name equals Alice, age equals 30, city equals New York, and the function would just know what to do with each piece of that named information.
So, when you start putting all this stuff together, defining functions, calling them, using arguments, returning values, you really are unlocking a genuine programming superpower.
And this quote right here, this really gets to the heart of it. Yeah, abstraction sounds like a fancy academic word, but all it really means is hiding the complicated stuff. You don't need to remember the details of how the square function works every single time you use it. You just trust that when you call square of 6, you get the right answer back. That's abstraction.
So let's do a quick recap. Why is this such a game changer? Well, you write less code, which is always a win. Your code becomes way easier to read because a good function name tells you exactly what it does. Fixing bugs becomes so much simpler, and maybe the most important thing of all, they let you take a giant, scary problem and break it down into small, bite-sized pieces that you can actually solve one at a time.
So, by getting a handle on functions, you're not just writing lines of code anymore. No, you're building your own custom tools. You're creating your own library of solutions. Honestly, the possibilities are just endless. So, the only real question left is, what awesome thing are you going to build first?